Chapter 3, problem number 54, page 77. Two friends, Barbara and Neil, are out rollerblading with respect to the ground. Barbara is skating due south at a speed of 44 meters per second. Neil is in front of her with respect to the ground. Neil is skating due west at a speed of 3.2 meters per second. Find Neil's velocity as seen by Barbara. Okay, so this is a relative motion problem in 2 dimensions. Okay, so let's do Barbara's given information. So Barbara is skating due south, so 4 meters per second at 270 degrees. Okay, and I don't put a negative sign in front of the 4 because I already have the direction noted, 270 degrees. Neil is in front of her. With respect to the ground, Neil is skating due west at a speed of 3.2 meters per second, and west would be 180 degrees. So that's the velocity of Neil. Now both of these are with respect to the ground, so I put a second subscript there, G. Find Neil's velocity as seen by Barbara. So we're looking for the velocity of Neil with respect to Barbara. So that's V, N, B. Now we use the Galilean transformation, which tells you how to add vectors together like this. So we know that VNB plus VBG should be equal to VNB. You see these two subscripts here are side by side. Okay, that's what you want to look for. Now I'm going to draw a sketch, just a rough sketch of this situation. So we have Barbara, VBG, with respect to the ground, and we add to that VNB, which is the unknown, and we should get this should be VNG here. Okay, so this should be VNG. So VNB plus VBG is VNG. So VBG plus VNB, which we're looking for, should give us VNG, which is 180 degrees. So you have to think, okay, so we have a result, an arrow pointing to the left. So how should VNB be pointed? Okay. There we go. So that when you add a VBG to VNB, you get a vector pointing to the left, which is the VNG. Excuse me. Okay, so this is the vector we're looking for. Okay, so we can use trigonometry. So the magnitude of VNB is equal to the square root of VNG squared plus VBG squared. And the angle, okay, let's see, why don't we find this angle here, theta. Okay, the angle would be equal to the arctan of VBG, the side opposite the angle theta, divided by the adjacent VNG. Okay, so let's do the numbers. Okay, so VNG squared, so we have 3.2 squared plus VBG is 4 squared. Okay, here arctan VBG is 4 and VNG is 3.2. Okay, so let's see what we get. Okay, now where did I put my calculator? I'll just use my iPhone. So let's see, calculator, scientific. scientific. All right, so let's see, 3.2 squared plus 4 squared, 16, equals, and I take the square root of that, and I get 5.122. Okay? So this here is 5.122 meters per second. The angle, take 4 divided by 3.2 and do the arctan, and I get 51 degrees. Okay, now let me just check if they want us to reference the angle to anything in particular. Okay, so the direction should be relative to due west. Well, 51 degrees is relative to due west, so that would be 51 degrees north of west. So our final answer is VNB is equal to 5.122 meters per second at 51 degrees north of west.